Okay, so the second section we're going to look at for this week is 7.3. And this is on some properties of logarithms. Right? So we're going to learn first some special patterns we can use with logarithms. And then we're going to learn how to take logarithms and split them or combine them. So it's kind of like, how do you combine like terms with logarithms? All right, so the first thing we're going to look at is 4 properties. And these properties are not really something you have to calculate anything. It's more of a pattern. But if you see this type of pattern, then this is the answer. So let's start with this one. That's a to the, if you have any question about what's an exponent and what isn't, just let me know. But that's a to the power of log base a of m. Here's an example with numbers. 3 to the log base 3 of 5. When you have something that fits that pattern, the key is these two things have to match. If they match, then the answer is whatever number is sitting right there. So the answer comes out to m. So in this problem, 3 to the log base 3 of 5, the answer would be 5. It's a special pattern. Now, if these numbers are different, then it doesn't work. This pattern doesn't work. Let me show you how that would look on the calculator. Let's take 3, raise it to log. I can't do it like that. I have to do alpha f2. So log base 3 of 5. Okay. So now I've typed in exactly what I have in blue. When I hit enter, I get 5. You will always get whatever number is right here for the answer over there. That's how it works. So any question on that special pattern? Now, if you change it, we just mess it up. And let's make this base a 2. Well, now we don't have any way to do that. All right, not quickly. We need a calculator. Because these two numbers don't match, when you hit enter, the answer you get is not the number that you typed in. These numbers have to be the same for that pattern to work. Okay, so that's our first property. And I will show you why some of these properties are true. I'm not going to do that one right now. Okay, let's look at the second one. So the first one was an exponential equation. The second one is a logarithm equation. And you might look at the first one and say, yeah, but the first one has log in it. Why is it exponential? Exponential is anything that looks like this. That is exponential. No matter what you put up here in the exponent, it's still exponential. And you have something raised to a power equals that. Now, this is different. This is log form. Log form always looks like this. Log, something here, and then you put something on the other side. That's very different than exponential. Okay, so what's the pattern here? Pattern here is if you take the log and the base on the log matches the base on your argument, then the answer is whatever number was right there. Okay, so that's another special pattern. So I want to look at why this one is true. So in log form, you have 3 things. You have a base, you have an argument, and then you have what's on the other side. I want to take those three things and change it to exponential and see what it looks like. All right. So in number 2, what's the base on my log? A. Yeah, and I'm going to write something that looks like this now. But that's exponential. So A is my base. And logarithm always equals what kind of number? Logarithm is always equal to the exponent. So that R is going to be my exponent. So I use this. I just use that. And what's the only thing that's left? The argument. And what's my argument in this case? A to the power of R. So what rule 2 is saying is that something is always equal to itself. Yeah, of course. Something always equals itself. In algebra 1, you'd probably see something like x equals x. And they might call that the reflexive property. Something is always equal to itself. This is that same idea, but it's written as a logarithm. So it's written in a fancier way, but that's what it really means. Something equals itself. Here's our third problem. It says that if you take the log of 1, the answer is always 0. It doesn't matter what the base is. If you take the log of 1, the answer is always 0. Let's write that in exponential form, and you'll see pretty quickly why that one's true. Here's your three things. What's my base? A is my base. And Curtis logarithm always equals what kind of number? Exponent. That always equals the exponent. So that's my exponent. And what's the only thing that's left to put on the other side? The argument, which in this case is what number? 1. So what rule 3 is saying is if you take something and raise it to the 0 power, you will always get the number 1. And yeah, that's a basic idea from algebra 1. Anything to the 0 power, just type in a negative number, raise it to the 0 power, you get 1. 478 to the 0 power is 1. Anything to the 0 power is always 1. And that's why rule 3 is true. Okay? And let's look at rule 4. So rule 4 says that if you take a logarithm and the base and the argument match, the answer is 1. And let's see why that one's true. Since I have two A's, I'm going to make one of them the red A and the black A, so we know which one we're talking about. All right, so if we look at that formula, is that formula a log equation or is that an exponential equation? That's a log equation. So let's change it to exponential and see if that makes it obvious why that is true. Because looking at it as a log, you might not understand why it's true. All right, Tyler, what's my base? Which one? Yeah, the red one, right? So yeah, the red one is my base. Let's make that my base. Dominic, what's my exponent? 1. So logarithm always equals your exponent. And Tony, what's left to go on the other side?
Argument.
The argument, which in this case is?
Black A.
The black A. Yep. So what rule 4 is saying is if you take something and raise it to the first power, you always get the same thing back. And that's always true. Raising anything to the first power will always give you back the same thing you typed in. So the reason why some of these formulas is true is it's not really complicated. It's just if you see it written this way, you might not recognize why it's true right away. So those are the four formulas, or four properties that we're going to take a look at. So now we're going to use these properties to try to simplify some examples. Right? So the way you do it is you look at your problem, and you try to match it up with one of these properties. So the first one is 2 raised to the log base 2 of pi. Does anybody see which property 1 through 4 that one looks like? Yeah?
What?
Yeah, it's property 1. The only thing we've done is we've made a equal to what number? 2. And we've made m equal to pi. So according to property 1, what would all that simplify to? Pi. And the only reason that works is because these 2's are the same. That's how you can do it so quick. So there's our first one. Let's try that one. Log base 0.2 of 0.2 to the negative 4. Which property, Tony, does that one look like?
Number 2.
Yep, that's property number 2. So using property number 2, can you tell me what that would simplify to?
Negative 4. Negative 4.
Yep, negative 4. So the answer that you get when you have this pattern is whatever number was right there. That's what it all simplifies to. So in our case, negative 4. Again, if you change it, so one of these is a 0.2 and one of them is a different number, and you can't really do it without a calculator. Let's try this one. The ln of e to the kt. So you might have to look at that one a little bit, but it is one of the patterns. You may have to do something with this that I talked about in the homework problem. But which rule is that? Yep.
2.
It is rule 2. Can anybody rewrite this to make it more obvious that it's rule 2? Yeah, Alex?
Log base e of e to the power of kt.
Yep, perfect. ln really means log base e. So if you rewrite ln the long way, then you can see you have 2 things that match there, and it's exactly the same as those 2 things matching right there. Right. So Alex, based on that, what would that simplify to?
Kt.
Kt, whatever k times t is. Okay. Any question on it? Let's do another one. Let's do log base 7 of 7. Okay, what's log base 7 of 7? The opposite. That's 1. That's property 4, where you're taking the log and the base and the argument match. All right, I guess we can go one more. Let's do e log base 6 of 1. Well, what would that come out to? 0. Doesn't matter what the base is. Anytime you take the logarithm of the number 1, the answer is 0. Because you're basically asking the question, 6 to what power is going to give you the number 1? Well, the only thing you can raise 6 to get a 1 is 0. Anything to the 0 power is 1. Okay. So any questions on those properties? All right. So first part. And let's look at the second part. So the second part is some properties that we can use to combine and separate logarithms. So let me show you something on the calculator, and you might be able to guess the first property. If I take the log of 4 and I add the log of 5 to it, first of all, there's no base written here. When base isn't written, what is the calculator assuming I want to use? Yeah? 10. So if I take log 4 plus log 5, I get that. Now, if I take the log of 20, I get that. Does anybody have an idea how I combine log 4 and log 5 to get this? So you multiply. Yep. You multiply. So what if I had like log 3 plus log 6? What would that be the same as? Log of 18. So it's not, you don't add these two together. You might think, oh, 3 plus 6 is 9. That's not how it works. You multiply them. So if you have two logs that are being added together, you can combine them into a single logarithm by multiplying what's here times what's here. And likewise, you can do it in reverse. If you had, say, the log of 50, can somebody give me two numbers that multiply to give me 50?
25.
So it should be the same as log 25 plus log 2. Yep, same thing. How about two different numbers that multiply to give me 50? What is it? We could do 50 and 1. But we know the log of 1 is just going to be 0, so that doesn't do anything. Yep.
5 and 10.
We could do 5 and 10. 5 plus log 10. Any two numbers that multiply to give you 50, if you add them as logarithms, you'll get the same answer. You could also do log of 100 plus log of a half, because 100 times a half is also 50. So that's how that property works. If you're adding two logarithms together, you can combine them by multiplying. Here's another example. I think we already did that exact problem. How about if you were subtracting two logs? If you add them, you can combine them with multiplication. What do you think about subtracting?
You divide them.
You can divide them. Yep. So if you have a difference of two logarithms and you want to combine it into one, you can divide m by n. You have to divide them in the order they were subtracted. The first one goes in the numerator. The second one goes in the denominator. And here's another example with numbers you could try if you want. But the log of 4/5 would have come from the log 4 minus log 5. Now, one thing I didn't mention here is the base started as a. When it was split apart into two different things, what was the base on each one of them? What was it?
A.
It was a. The base starts as a. It stays as a. The base doesn't change for the whole problem. So you use whatever base they give you and you keep it the same. Whether you're taking something and splitting it into two logs, or you're taking two logs and combining it into one. Keep the base the same. Right? And our third property. The third property says that if you have an exponent on an argument, okay, m to the r, that's the argument. If you have an exponent on the argument, you can put the exponent in front. So in a logarithm, exponents on arguments are allowed to be moved to the front. Just like that. So I have log base 10 of 3 to the 5th. I'm allowed to take the 5 and put it in front. The only reason I can do that is because it is in a logarithm. In general, you can't just take exponents on numbers and move them to the front. The only time you can do that is with logarithms. Okay, let's try it. Let's take the log of 3 to the 5th. First of all, is what I just typed in the same thing as what I wrote on the board? Yeah. I didn't write the base, and that's okay. So I get that number. Now let's take 5 log 3. Took the 5 and moved it in front. Same exact thing. So how would you know when you're doing a problem if you're supposed to move that to the front? Well, in the directions, if they say to write powers as factors, that's basically saying do not leave exponents in the answer. Do not leave anything as an exponent. Move it in front as multiplication. That's what factor means. It means it's multiplied in front. I'm not saying every problem is going to have powers, but if they do, move them to the front. Okay. So what they want us to do with these is to take something that's already a single logarithm and split it apart into 2. Okay. So when I split this apart, what operation is happening right here between the 3 and the x? They're being multiplied. How does multiplication split into 2 logarithms? Is it addition or subtraction? It's addition. So we're going to split this into 2 logarithms. What's going to be the base on each log? The base stays exactly the same as the original. So keep the base as 4. And Tony, what's going to be the argument to my first log?
3.
A 3? And how about the argument to my second log?
X.
X. Perfect. And that's how you express this as a sum of 2 logs. Later, we're going to do the opposite. We're going to take that and combine it back into 1. But that's how you split it into 2. Let's try this one. Log base 2 of 5r cubed. Okay, so first thing to recognize is what operation you're doing inside the parentheses. And that's going to tell you if it's a sum or a difference when you split them. Sam, what operation are we doing in the parentheses?
It's multiplication.
It's multiplication. And when we have multiplication, Grady, how does that split? A sum or a difference? So on the last one, how did we split it?
Addition.
Addition. So we're gonna split this one as addition. Somebody tell me what's going to be the base on each log. 2. Okay, so base on each log is going to be 2. What's going to be my first argument? It's going to be 5. And what's going to be my second argument? R.
Would it just be R? You can move 3 in front.
Well, we'll do it in 2 steps. Or we can do it in 1 step if you want. So before you move it to the front, what would you put right here?
R to the 3rd.
R to the 3rd. But then, what did you say to do with the 3 that would be right here? Move it to the front. So this would have been r cubed, but the direction said not to leave exponents. That's how you. Okay. Any questions on that? Let's try this one. Log base 9 of x divided by 2. All right. So Abigail, what operation do we have inside the argument? Yep, we've got division. And Gavin, how does division split into 2 logs? Which operation? So this would be property, well, this would be rule number 2 out of the 3 we just went over. Not sure?
No, not sure.
Anyone help them out? How does division split apart? Yep.
Subtraction.
Subtraction. You have division of 2 things. It turns into a subtraction of those 2 things. All right. Let's write it as subtraction. What's going to be, Tyler, what's going to be my base on each one?
9.
Yep, the base stays exactly the same all the way through the problem. So base 9, should give some more space over there. And Jackson, what's going to be my first argument?
9. Or no, sorry, x.
Yep, so x, and then my second argument? 2. Perfect. So that's how you deal with a division problem inside the log if you want to split it apart into 2 separate things. Any questions on that? Try this one. Now, let's just go through the different bases we've done. First problem was base 4. Then we had base 2. We had base 9. This one's base e. You don't write it as log base e. You're going to just use the ln symbol. But it's the same as every other problem we've done. Just write ln instead of the word log when you split it. All right. So Kiana, what operation do we have inside the parentheses to our logarithm? That's division. And Dominic, division going to split as subtraction. We're going to have 2 ln's. Yeah. Austin, what's going to be the argument to my first ln?
Y3.
Y
squared.
No, not
Y
squared. Cubed, yeah. So y cubed. And Alex, what about the argument to my second logarithm?
8.
Yep, 8. Okay. Now we've split it, but they did say do not leave exponents. They said express powers as factors. So Tony, what do I need to do with that 3?
You gotta move it up to that part.
Yep. So can you tell me what my final answer would look like?
3 ln y
Yep.
minus in
Minus
ln.
ln. Yep, natural log. So 3 ln y minus ln 8. Question on that one? Okay. Let's try this one. So when we look at what's happening inside the parentheses, there's a few things happening, but what operation do you see in there right away? Division, right? There's a division. If you see a division, you deal with the division first. So we're going to have 2 ln's. Dominic said it's division, so we're going to put a subtraction sign. And what's going to be my first argument? Yep.
X squared.
X squared. And what's going to be my second argument? X minus 1 cubed. You do need to keep that x minus 1 cubed in parentheses, because if you don't, it looks like you're cubing the number 1 and you're not doing anything to the x. Okay, so keep it in parentheses. All right, now we just have to fix both of those. How would we fix the first one so that the exponent is a factor and not an exponent? Okay. Yep, and what would that, how would you read it?
In front of the ln.
Yep,
So it would be 2 ln x.
2 ln x, perfect. Minus, and what would be my my second term? Of 1. What would be my second term?
3 ln x.
Yep. Minus 3 ln x minus 1. Okay, so that's how you take something that's all together in one log and split it into 2. Is there any questions? We did like 5 examples of that. Any questions on taking something and splitting? Right. Now we're going to reverse it. We're going to take something that's split and combine it back together. So it says combine the following into a single logarithm. So now you want to think of every step we just did, but in reverse. If you look at this problem, the first thing you want to think about is something that could move back to a different spot. Anybody see something that they think needs to move back to the spot that previously we were moving it away from that spot? Yeah?
The 4 in front of log.
Yep, the 4 in front of that log base A. Where's that 4 going to go?
It's going to be 3 to the power of 4.
So yeah, we're going to have log base A of 7 plus log base A of 3 to the power of 4. Now, since we have a number here, we might as well do that out. 3 to the 4th power means 3 times 3, and then another 3 times 3. So what is 3 to the 4th power? Yep.
81.
Yeah. And if you think of it as a 3 times 3 and another 3 times 3, so 3 times 3 is 9, another 3 times 3 is another 9, and 9 times 9 is 81. So let's do that. Now we're at the step where we want to combine this all into a single log. When I write it as a single log, what is going to be my base? A. It's the same as the base that we've had the whole time. And now we had plus. So if this is a plus, how is the 7 and the 81 going to be put together? You don't add. Yep.
Multiply.
7 times 81. So that's log base A. 7 times 81 is 567. Right? And that's how you recombine something back into one log. Any question on it? Let's try, I got this one. Let's see if we can do the whole thing in one step. It's 2 log base 3 of u minus log base 3 of v. Okay, when you do the homework, you might see something like this. Off to the side. That's just saying that u and v are positive numbers. Because we talked about if you plug a negative in, you're going to get an imaginary answer. So this doesn't really have any effect on how we do the problem. It's just telling you that the u and the v are positive numbers. That's all. No negatives. But sometimes people look at that and they just get confused. All right. So when we recombine it all together, what's going to be the base on my list? Yeah, base 3. And then we have a subtraction. When you combine it together, subtraction turns into division. And what's going to be in the top part of what you're dividing?
U to the power of 2.
Yep, u to the power of 2. And what about in the bottom? Just v. There you go. And that's how you combine it all together into one logarithm. Question on that? Try one more of those, and then we'll look at the last thing we're going to do, which is on the calculator. Let's try this one. Let's see. I'm going to change. Actually, that might be okay. Let's do that. So we're going to combine this all back into one logarithm. So when you recombine it, you're going to have a single ln. And how about, Cameron, what operation are we doing the way the problem is written between the two logs? No, the way it's written. So we have this, and what are we doing with the two? All right, so what operation did we say we're doing between the two logs?
Subtraction.
Subtracting, and subtraction, when you recombine it, turns into division. Okay, let's start with the top. Sam, what's going to go on the top?
8 to the power of 2/3.
Okay, yeah, so we use our calculator for that. Or I'll just tell you what it is. 8 to the power of 2/3. And now, in the bottom, we might as well simplify 3 to the 4th minus 8. We just did 3 to the 4th on the other page. What was 3 to the 4th? 81. So that part's really 81 minus 8. So we might as well just put that all together. What's 81 minus 8? 73. And on your calculator, we can do 8 to the 2/3 power. And we're going to get 4. No, I didn't type it. Trust me, it's 4. So you get. So this ends up reducing to the ln of 4 over 73. Which, if they wanted a decimal for that, you could just go into your calculator, press ln, and do 4 divided by 73. I'm not going to write the decimal because that's not what this question was about. You could if they wanted you to. All right, so when we do logarithms on the calculator, we only have two buttons, right, for logs. We've got that button, and if I press that one, what base is the calculator going to do? 10. And then what if I press the button below it? That's going to do base E. Those are the only two buttons you have on the calculator for doing bases, 10 and E. So, depending on your calculator, you might have a button that allows you to type in something with a different base. But even if you don't, you can still type it in. So what I'm going to show you now is how could you type something like this on the calculator. It's not base 10, it's not base E, it's base 6. And to do that, we need to use what's called the change of base formula. So change of base formula allows you to plug a log in on a calculator, but it's not a base 10 and it's not a base E. And this will work on any calculator that has a log button. Some calculators may have a special feature to type something in that's not base 10 or E automatically. But I'm going to show you how to do it for any calculator, even if it doesn't have a special feature. And there's actually two ways to do it. They come out exactly the same, and they're the same amount of work. Where did I write it? Right here. So that's one way to write the change of base formula. I didn't put any bases on these two logs. So that's base 10 on the right. If you have a log and the base is not a 10 or an E, you can take the log of the argument, put that in the top, and divide by the log of the base. That's the change of base formula. And it doesn't matter which log button you use. You can take the common log of the argument and divide by the common log of the base, or you could take the natural log of the argument and divide by the natural log of the base. Don't mix them. Either use all common logs or all natural logs, but it will come out the same. It is important which number goes in the top and which number goes in the bottom. Remember, if this was lined paper, think of the A as being below everything. The A is under the line, so the A goes in the bottom. The M is above the line, so the M has to go above the line in the fraction. It goes in the top. Let's try this. So I want to know what log base 5 of 12 is. I want to type it in on a calculator so I don't have to do anything special with the base. So I'm going to have to rewrite it as a fraction. And can someone tell me what would go in the top of the fraction? Yep.
Log 12.
Log 12. And what would go in the bottom? Log 5. What's another way you could have written it if you didn't want to use log? Common log. Yeah?
ln 12.
Yep.
Divided by ln 5.
Divided by ln 5. Right. Let me type that in. Show you how it works. So log 12, we're going to divide by log 5. So the answer is 1.54. Generally, we'll go to 3 decimal places. So let's go 1.544. Now, so you did it with ln's. So ln 12 divided by ln 5. If you actually type in divide, you will get the same. 1.54. Now, well, let's talk about that last one. What did I do wrong there? I did what? I didn't put the division sign in. How about if I did something like this? That's wrong too. What's wrong with that one?
It's the common log of the common log.
Yeah, I did the log inside the log. I don't want to do a log in a log. What this one really means is this. ln 12, let me write up this. ln of 12 divided by the ln 5. That's not what you were going for. Okay, you need to close that parenthesis when you're done. All right, now think about that number for a second. 1.544. Logarithm always equals what kind of number? It always equals an exponent. So think about the original problem. At one point, we didn't know what it equaled. So pretend it equals x. What's your base here? 5. What's the exponent? X. And what would go on the other side? 12. So what we really just figured out in this problem is 5 to what power gives you 12? And it's the 1.544 power. 5 raised to the 1.544. It's about. So I told you at the beginning of the week, at first, we didn't know how to solve something where this number wasn't a power of that number. Now, we do. We can raise any number to a power and figure out what the answer would be with a logarithm. All right. How about this one? So if you want to think of this as an exponential problem, this is what it's asking you. 3 to what power gives you 16? That's what I want to know. Well, what two numbers do we know x has to be between? We don't know what it is exactly, but we can say it's between this and this.
1 and 3.
So 3 to the second power is 9. That's too small. 3 to the third power is 27. That's too big. So it's somewhere between 2 and 3. What is it exactly? Well, let's do this. What would go in the top?
Log 16.
Yep. And since Tony decided to use logs, we have to stick with logs all the way through the problem. And what would go in the bottom? Log 3. So let's see if we get something that's in between 2 and 3. Log 16 divided by log 3. Perfect. 2.524. Okay, and then remember what you really just did. You just found an exponent. Because logarithms always give you exponents as an answer. That exponent. So that's called the change in base form. Okay, any questions on that? So 3 things we looked at today. The properties, which is a pattern you got to recognize. The combining and splitting. And lastly, the change of base formula. So that's homework for tonight. You will need a calculator to do the change of base formula problems. But it doesn't have to be graphing. Any scientific calculator will. Reminder that I will be after school tomorrow because we have our test on Thursday.